Hello, my name is Gonzalo Mercado Espinoza, and I'll be explaining the CPU cache. So, the CPU cache is this tiny shortcut that makes computers feel fast. This is one of those hidden computer parts you don't usually think about, but affects how fast your laptop, phone, games, and even apps feel every day. So, as we move on, we see that it's similar to cooking. Imagine you're cooking, you keep salt, oil, and your favorite tools right on the counter because you use them a lot, right? You're going to be cooking, you're going to be using them. So you don't want to walk to the pantry every single time. A computer does similar things. It keeps important information close by, so it doesn't have to travel so far to get it. Moving on, let's talk about some background of CPU versus RAM. The CPU is like the brains of the computer. It works extremely fast. RAM is where the program and data are stored while the computer is running. RAM is much bigger than cache, but it's farther away from the CPU. So getting information from RAM takes more time. So we come up with this idea of how can we get this data information closer to the CPU or faster CPU because the RAM is so far away. So this is where we discuss the topic about cache memory. Cache memory is a tiny amount of very fast memory located right next to the CPU. Its job is to hold data and instructions that the CPU is likely going to use. The easiest way to remember is think about it like cache is small, fast, and close. So, how does the cache memory actually find this data that it's looking for? This is where we go to cache hit versus cache miss. So, when the CPU looks in cache and finds what it needs, that's called a cache hit. It's like searching for something. It's let's say the CPU says I need this. The cache is basically checks and sees do I have it? Do I have it? Yes or no. When we have it, it's called a hit. That means it's very fast because we found it in the cache. When the CPU looks in cache and does not find what it needs, this is called a cache miss. We couldn't find it. So what does it do? It goes to the RAM, which takes even longer to get. So a cache hit is like finding your pencil on your desk. It's right here. I can get it really quick. However, when we miss on the cache, that's like searching your whole backpack for the pencil. So let's get a little closer look by doing a step by step. So here's the process of how the cache works. First, the CPU asks for data. It's saying, I want this specific data, and it goes and requests it. Second, it checks the cache, okay? Because maybe we can have it closed, we can get it quickly, so it checks it. Third, the data is not there. So what do? We go to the RAM. Fourth, once it gets the data, it keeps a copy in the cache so it can use it next time for a faster load for the data. Why? So this is why computers are good at speeding up repeated actions because it's able to know. Moving on, we're gonna talk about multi-level caches. So most CPUs do not have just one cache. They actually have three levels to it. We have L1, L2, and L3. So let's start from the bottom. L1 is the fastest and smallest because it's right next to the CPU. L2 is a little bit bigger and a little slower. And L3 is even bigger and and honestly, it's shared by the CPU cores. RAM is much larger but slower compared to the other three caches. So the main rule is to remind all these is that closer usually means faster. And let's get a quick understanding by an example. So an example we have is, let's say a program is using the small list of numbers again and again and again. The first time, the CPU may need to get the numbers from RAM, but after that, the numbers can stay in the cache. Now the CPU can reuse them quickly. This is why loops, games, and apps can run faster when they reuse nearby data. So this is why we just keep stuff in the cache because we can easily repeat the same data. So let's talk about cache and why does cache even matter? Why do we have in them? Why do we have them in computers, laptops, all of our technology? So it matters because it helps everyday technology feel more responsive. What is responsive? It means it feels almost a smooth finish when you're using technology. When a game loads repeated textures, when a game When a website reuses information, when your phone opens the apps again and again and again, it feels more smooth. Cache helps reduce this waiting time of opening one app and then you open this other app and you want to go back to the same app. It feels like a quick transition. It feels so smooth. It can also save energy because the CPU doesn't always have to need to reach farther information into memory. So this is why we actually really like cache in technology and why this architecture is such an important thing that we need in technology. So if we're gonna recap, let's talk about how CPU cache is very tiny. We talk about how fast it could be, and why is it fast? Because it's right next to the CPU. A cache hit means that the CPU quickly finds what it needed. It's right there. We can access it right away, and we found it. A cache miss means that the CPU has to wait for a slower memory, which means we looked in the cache and we couldn't find it. So what do? We go to RAM. So next time you feel that your laptop or phone feels a little bit faster, or you're like, wow, that was really smooth, like I opened that app really quick, remember that one reason is that the cache really made that happen because architecture really helps you create this smooth transition into technology that makes your phone even feel better than before. Thank you for listening to my video. I hope you learned a little bit more about cache, and if you have any questions, please drop them down in the comments, and thank you for your time.